What's up, guys? Today we're going to solve problem 3 sent to us by dailycodingproblem.com. Good morning. Here's your coding interview problem for today. This problem was asked by Google. Given the root to a binary tree, implement serialize root, which serializes the tree into a string, and deserialize s, which deserializes the string back into the tree. For example, given the following node class here, the following test should pass here. Now this is written in Python. We're doing this in Java, so I'll be using the Java equivalent to this and to this here. Okay, let's read this problem and make sure we understand it. So we're given a root to a binary tree, and we need to implement a serialize method, which will take the root as a parameter, the root node as a parameter, and it converts the tree into a string. So it's basically like a two-string method for a binary tree. And then we need to implement deserialize, which does the exact opposite. It takes the serialized string as its parameter, and it turns that back into a binary tree. Now, dailycodingproblem.com has deemed this problem as medium difficulty. I, who am not affiliated with dailycodingproblem.com at all, hereby deem this problem as hard. Anytime you have to use recursion and trees, things can get kind of complicated. So how do we want to solve this serialize method? Well, what we can actually do is we can create a string builder object. We can then recurse through our binary tree using a pre-order traversal, and along the way we will append the values to our string builder object. So let's start putting that into notes. So first thing I said was create a string builder object. Easy enough. Next, we will do a pre-order traversal of the tree. Next, we will append values from that tree to the string builder object. Now, this is a very simplified version of what we're actually going to implement, but going off of this, we can write our method. So let's talk about how we want to solve deserialize. Now, this one's going to be more complicated. What we are going to do is we're going to use an intermediary data structure to store the values from our serialized string. So for that, what we'll use is a queue. And we'll use that to store the serialized string values. Then we will recurse. We'll use recursion again, and we'll recurse through this queue. So let's say recurse through queue. And we will remove the head from the queue and create a new node using that value. Alright, this is also very simplified, but this is going to work as far as notes we can go off of to actually write these methods. And let's just start doing that right now. Alright, so we'll start with our main class here. Next, we're going to need a nested node class here, and that can be seen right here. Alright, so let's do that. Now, for this node class, we're going to need 3 different constructors. And I know that because looking right here, first off, this self object here, its equivalent in Java is the this keyword. So we're not going to have this in our constructor. But in this example here, you've got a value, you've got a left child, and you've got a right child. So we're definitely going to need a constructor for that. But when you look at this example right here, you can see that there is a node object here which has a value and a left child but no right child, and then you can see there's a node right here that just has a value with no left or right children. So we're going to need 3 constructors to be able to construct these 3 objects needed for the test. All right, so let's go ahead and let's create the values that we'll be using throughout this node class. So we'll create the instance variables that represent this. Now, their value in this test, or dailycodingproblem.com's value for this test, is just a string. So let's do the same thing. Let's create a string for our value. And we'll just call it val. All right, next we have a left child and a right child. All right, now let's create the three constructors that I was referencing just a second ago. First one, we will just create the constructor that's going to take a value and nothing else. All right, next let's create one that will take a value and a left child. All right, and finally let's create one that can construct an object with all three. And I know it may be kind of tedious to watch this, but when you're doing this on your own, I'd recommend just typing everything out rather than copying and pasting anything. All right, so we've got our nested node class here. Now let's create the constructor for our problem 3 class. And this is where we'll create our test cases. And in the notes for our serialize method, we know we're going to need to create a string builder object. So let's go ahead and create that as an instance variable. All right, and let's just jump right into creating our serialize method. So this serialize method here, again, we know it takes a node as a parameter, but it also needs to return a string. And I know that because right here we can see that the deserialize method needs to pass in a call from this serialize function. And we know the deserialize method takes a string as its parameter. So we know that we need to return a string with this. Not a string builder, just a string. And we need to take a node as its parameter. Okay, so what do we have in our notes? So we need to do a pre-order traversal of the tree, and then during which we need to append the values to our string builder object. So first, let's just say if the root is null, this will serve as our base case. What do we need to do here? Well, that null needs to be represented in our string builder object because that is that's a legitimate. Well, it still represents a left or right child, or potentially a root. So let's go ahead and do that. So we mentioned in our notes we need to append that, and it needs to be represented. So of course it needs to be represented as a string. Now we actually need to append something else to this. We need to append something that signifies a pointer to the next node, and that's going to help us understand this, and it's also part of the requirement. So to do that, let's just use this as the delimiter or as the pointer, and hopefully that'll be clear once we start printing this out that that's what that is meant to be. And finally we'll return the SB2 string. Now if it's not null, what we need to do is we need to take the value from that root and append it to the string builder just like we did here. So if not, we'll simply take the value from that node. And then we also need to go ahead and append our delimiter, or our pointer I should say, to our next node. Now this is a pre-order traversal, recall. So what we will do then is we will call the serialize method recursively on the left child of the root. And then we will do the same thing on the right child of the root. Finally, we will return the string. Okay. Now let's just go ahead and test this real quick. I think this will work, but let's do just a quick test to see if this does what we expect it to do. So we'll just instantiate our problem class here. And here, let's just create a simple test node. And let's just call it test. And then let's go ahead and call our serialize method. See what it gives to us. Passing in node. So what this should do is it's not going to be null, so it will come here and it's going to take the value from that node, which is the word test, the string test, and then it's going to append this to it. Then it's going to call it on the left child, which is null. So null will be appended to that, and then it will append this. Then the same thing will repeat for the right child. So once this prints out, it should look like this. So we've got test, then we've got our pointer to the left child, which is null, and the pointer to the right child, which is null. And then remember, we're tacking on another pointer right here whenever we do this. Really, this one refers to this pointer right here. So it should look just like this. So let's test it to see. And that's what it looks like. Okay, so let's move on to the deserialize method, and let's reference our nodes for that. So for deserialize, what we want to do is we want to create a queue to store the serialized string values. All right, and another thing is we need to return a node with this deserialize method. And I know that because you can see right here, this needs to represent a node because we're calling the left child of that node and then the left child of that node. So therefore, deserialize must return a node. So let's code this up accordingly. Also, this takes a string. All right, that'll work. So first, let's do just some defensive programming here, and say that if this has a length of 0, then we return null. Alright. Now if it is not, we need to go ahead and, again, we're creating our queue and we're storing the serialized string values. So we're going to be using the queue interface for this. And we'll call this a queue. And since it's an interface, we cannot instantiate this queue object directly. So we'll implement it using a linked list. And then we want to go ahead and add all of the values from the serialized string into the queue. We don't want these delimiters here. We just want the values. So for the last one, the queue would say, for example here, we would just be storing test, null, and null. But the string will actually contain test, then our pointer, then null, then another pointer, and so forth. So we want to make sure it only has the values. So what we'll do is we'll actually use this add all method from the queue interface, and then we will put in these values using an arrays as list method, or the arrays as list method. And then we can actually call the split method from this and pass our delimiter in as the regular expression. So what this will do is this split method will return a string or an array of strings. So you can see that this actually returns an array of strings, and it does so by splitting off the values around this value, or around this delimiter right here. This will convert that into a list, and it will all be added into our queue object here. And this queue, in this case and in most cases, is going to be a first in, first out data structure. And that's going to be necessary when we start recursing through it. So let's go ahead and work on that right now. Now, we can't really call this method recursively because in order to do that, we're going to need to pass in the queue each time. And in the instructions, only a string is given as the parameter for this deserialize method. So let's not deviate from that. Let's create another method that we'll use for the recursion. And we'll just call it build tree. And here we will pass in our queue. Now this is going to need to return a node as well. And it needs to take a queue as a parameter. Alright, so let's reference our notes here, see if we can remember what we had. So we've got this part here, we're storing these string values. Now we need to recurse through this queue, much in the same way that we did when in our serialize method. And we want to remove the head from the queue and create a new node with the value from the head. Okay? So let's do this. Let's create a variable to store that value right now. So what's important here is this queue is going to store these values in order, and this is going to remove the first value from that queue, and it's going to store it right here. So this is not going to go into an infinite loop. We are going to eventually run out of values in that queue. And now what we need to do is let's account for the null value within the queue. So let's say if val equals null. Now keep in mind, this is a string. We're looking at we're just looking at the string values. So right here in the serialize method, we check to see if root was equal to null. Now we need to check to see if it equals a null string. And if it does, we're going to simply return null. And hopefully this will make a little bit more sense in just a second. But next what we'll do, if the value is not null, then we need to go ahead and create a new node, which is going to represent a node in the binary tree that we're creating here. And we will create it using that very value. Now we're recursing through this much the same as we did here in serialize. So next what we're actually going to do is we need to create the left child for this node, and to do so we're going to call this method recursively, passing in the queue. And then we need to do the same thing for the right children. And finally, we need to return the node. So this will, this queue again is storing the values in order. So we're going to remove the first one, and we will create a new node with that. This will represent the root of our tree that we're recreating here. So this is going to be the root, and then its left child will be another call to this build tree. And if it's null, great, it will create the left child as null, and then it will return here and do the same thing with the right child. If this is another value, then that works too. Then we create the left child and we enter in the value for that. Alright, so we're going to walk through this again with an actual call and see if we can make sense out of it. And now let's just go ahead and create our test case here. I think we're ready for that. All right, so I'm just going to go ahead and copy dailycodingproblems.com's test case here, and let's just paste it down here and go ahead and recreate it and test it. And I'm doing this just so it's easier to see for you and for me. All right, so let's create the node object that corresponds to this node object right here in Python, but we'll be doing it in Java. All right, so we need root here as its first value. Then the left child is going to be a new node with left as its value. Next, there is another new node as its left child, and its value is left.left. And I'm looking at that right here. Okay, I'm creating the corresponding node object, and we're right here so far. Next, we need to go ahead and create the right child for our original node, and that has a value of right. So here's the root, here's the left child here, here's the left child to that right here, and then here is the right child right here, and this right child corresponds to this original node here. So let's print this out. Let's print this out, and then let's talk through that one more time because that was probably confusing. Okay, that looks correct. Now let's go through each one of these and see what corresponds to what. So here you can see, of course, root corresponds to this root right here. Next, it's going to go to its left child. Its left child is right here, and the value of that left child is right here. So this corresponds to that. The next thing it's going to do, it's actually going to go to the left child of this node, which is this node right here. And its value is left.left, which you can see right here. Next, it actually goes to the left child of this node right here. Left child of this node, which doesn't exist, it's null. So it's null. After that, it actually goes to the right child of this node right here, which is also null. All right. After that, it actually goes to the right child of this node right here, which is also null, and it's represented right here. Next, it goes to the right child of this node right here, which is right here. So, and the value of this is right, and you can see that represented right here. Next, it goes to the left child of this, which is null, and then it goes to the right child of this, which is also null. Okay, so now let's test our deserialize method. And we will call this exactly like they have in their test case. I'm a stickler for the rules, so let's do that. Let's do that. So here they just say let's call the serialize method. We'll pass in our node, and then we call left, and then we call left again, and then we call val. Tell you what, let's print this out first. Let's print this out first, and let's go ahead and put this on a new line. So what this is going to be is here's the root. So left is this one, and then the next left is this one right here, and the value of this is left.left. Right? So left. So let's look at it this way. This is the root right here. Left is this node right here. Left, this next left, is this node right here. And this value is this right here. So this should print out left.left. And that's what it does. And just to do it, just to test this the way they had it here, let's do that. So we need to actually call the equals method. No, not that. Yep, equals. And let's see if it's left.left. And I'm quite sure it is, so let's test that. And it's true, so that returns as true. So that test case does pass. Alright, that was a doozy. If you have any questions, leave them in the comments and I will explain them to the best of my ability. Otherwise, I'm going to be doing problem number 4 next, so that'll be coming soon. Alright.